This is a quick rundown of question number 5 from the section 3.5 notes on implicit differentiation. Now, there's a more detailed video posted in an old lecture video. This is just a quick run through of what's happening. So in question 5, we're asked to use implicit differentiation to find y prime. So that means we have to work with this given equation as it's written. And before you can find the derivative implicitly, you have to read the given equation really carefully. So we are given this extra piece of information here that's reminding us that y is a function of x. That means we're going to treat x like a variable. So whenever you see the letter x, you're treating it like a variable. That means x prime is 1. The derivative of a plain old variable is 1. And y, the letter y, is acting like a function. So when you see a y and you take the derivative of y, you're going to record it as y prime. And y prime does not equal 1 because y is a function. Y is not a variable, it's a function. Okay, so that's the first thing you have to get set in your mind before you find the derivative implicitly. Then you need to go through each piece of the given equation. So each piece of this given equation up here, you need to go through and slow your brain down and say, okay, what is this letter representing? Is it a variable or is it a function? What derivative rule do I need to be using to find this implicit derivative? And once you get all that sorted in your head, then you do the calculus. So this is what I did here. So I said, okay, I have the letter y. Y is acting like a function. Okay, so that means when I take the derivative of y, I'm going to record it as y prime. I'm not going to record it as a 1. Then I moved on to the next piece of information. It was an x side by side with a y squared. X is acting like a variable. Y squared, or y is acting like a function. So y squared is like a function. So I need the product rule here because it's two things. It's a variable and a function. Side by side multiplying, that's a product. So I went ahead and said, okay, my first term is the letter x. X is acting like a variable, so the derivative of x is a 1. The second factor is a y, which is acting like a function. So I did my power rule with a chain rule there, and I got that the derivative of y squared was 2y times the derivative of the base, which I'm recording as y prime, since y is a function. Okay, so that x y squared term needs the product rule. Then my next term over here, that was just an x squared. The letter x is acting like a variable, so I'm going to do power rule, and the derivative of the base will be 1. And then I had a constant 1. I know that derivative is going to be 0. And then on the other side of the equation, I had a constant 0. The derivative of a constant is 0. So I just went through, reread the equation several times until I knew, what is this letter representing? A variable or a function? What derivative rules should I be following to take the derivative of this piece of the equation? Okay, and then I just did that. So, okay, so I said, here we go. Y, the derivative of y is a function, so I recorded it as a y prime. Then that second term was a product, so I applied my product rule, and I had to put that product rule in parentheses because I was subtracting the result of the product rule. The result of the product rule happened to be a binomial, so I had to put that binomial in parentheses there so I could eventually I'm going to distribute that subtraction to each of those terms. Okay, and then I went through, okay, x squared, x is acting like a variable, so I did my my power rule, but the derivative of the base was just a 1, okay? And then the derivative of each of the constants was 0. So that's the hardest part. And that's where the calculus stops. The calculus is done here. The rest of the problem is just plain old algebra. Okay, so let's run through this algebra real quick here. Okay, so what's going on with my algebra? In my algebra, I distributed the subtraction to both terms of the product rule. Okay, so that's why both of these terms are subtracting. And then I knew I just had to get the y primes alone. Luckily, they're already on the same side of the equation, right? When I look over here, my y primes are already on the same side of the equation. That's awesome. So I just moved everything else over to the other side of the equation. And then to get those y primes in one location, I just factored it out. And then to get that y prime alone, it was being multiplied by a binomial. So I just divided both sides by the binomial. And that got me my y prime. And then once I did that, we were asked to evaluate that derivative for the ordered pair 1, 2. So when you read the ordered pair, it's always going to be your input variable. So that was my x. And then when I put x into the function, I get a y out. So this is going to be my y value. So I just plugged in those values, some plug and chug after that. That's telling me so y prime is telling me the derivative of the line tangent to the graph at this ordered pair. So if I could graph the equation that they gave me, and I could locate the ordered pair, the point 1, 2, if I located that point and I dashed in that tangent line, the slope of the tangent line would be negative 2/3. Okay, like I said, there's a much more detailed video and an old lecture video I posted. This is just a quick run through. Might need to watch it a couple times. Email me if you have questions, or reach out to our instructional associate or the Learning Lab. They should be able to help you with this at the Learning Lab because it's not business related. This is straight up calculus.